Hello students, welcome back. Now we are going to start, which is the most important part in this lecture series, that is previous year IIT JEE questions. So now in this part we are going to solve some IIT JEE questions which appeared in the examination in the previous years, right? So you will find that the questions were actually very easy if you apply the concepts that I have taught you, right? So let's start the part without wasting any time. So in this part we are going to solve some very simple problems which came in IIT JEE exams, right? And in fact they were very simple problems, right? Because IIT JEE exam never asks any difficult question, right? Always the questions are very simple, and you will come to know that if you apply the concepts that I have taught you, right, then these problems are actually very simple, right? So no need to be afraid. Take a deep breath and let's start with solving the first question. So first question is here on your screen, right? So first question is, let there is a function which is defined from R to R be such that f of 1 is equal to 3 and f dash 1 is equal to 6. Then we have to find out the limit. Here it should be x tending to 0, right? So in the question it is mentioned that limit x tending to 0 f of 1 plus x divided by f1 whole raised to the power 1 by x. Now if you apply this limit, if I put this x equal to 0 in this, I will get f of 1 by f of 1, which will get cancelled. So this is in fact 1 to the power infinity form in limits, right? So whatever is written here, this is nothing but 1 to the power infinity form. And how do we solve 1 to the power infinity form in case of limits? You know it well, right? So this will be solved by e to the power. We take e to the power, limit will remain same, limit extending to 0, fx minus 1 into gx, right? So gx into fx minus 1, so 1 by x, which is gx, right, into fx minus 1. So I will get 1 plus x divided by f of 1 minus of 1, right, e to the power gx into fx minus 1. This is how we solve 1 to the power infinity form. If you don't know this, you should revise the concepts of limits once again. So e to the power, I will get, this will be nothing but limit x tending to 0, and I can take LCM here, so I will get f of 1 plus x minus f of 1 divided by, and divided by here I will get x into f of 1. Now see, if I carefully see this quantity, what is this quantity? This quantity is something like, right, and including this also, right? So this is nothing but limit x tending to 0 f of 1 plus x minus f1 divided by x. This is just like limit h tending to 0 f of 1 plus h minus f1 divided by h, right? Just it is with that h is replaced by x, and here also x is tending to 0. So this is nothing but f dash 1. This given quantity, this realization is important, right? This is nothing but whatever this is written, this is nothing but f dash 1. So what will be my answer? My answer will be e to the power, this is nothing but f dash 1 divided by, this term is left out, which is f of 1. Now f dash 1 and f of 1 is given in the question, so the answer will be 6 by 3, which is e square. So correct option would have been C option. And this question was asked in IIT JEE 2002. Can you believe it? Such a simple question. This realization was important, right? It is obvious that if this is 1 to the power infinity form, you have to apply this concept of how to solve 1 to the power infinity form that you know, right, from limits. And here this realization was important, that whatever this is written is nothing but this is f dash 1, and that is pure definition of derivability, right? So just a question on the definition, that's it. Okay, let us go to the next question. Now again, this question is also very simple. It says that a function is given, right? This is the function which is given, mod of mod x minus 1 is differentiable for all real numbers except the points, right? So you have to find out where this function is non-derivable, right, where this function is non-derivable. Now to check whether this function is derivable or non-derivable, at which points, right, at which point this function is non-derivable, for that what we will do is we will plot the graph and check it, right? So how to plot the graph of this function? It's very easy in fact to plot the graph of mod functions, right? So first of all, tell me what will be the graph of mod x. The graph of mod x will be something like this, V-shaped. This is the graph of y equal to mod x. Now if I want to plot the graph of mod x minus 1, this part, right, mod of x minus 1 will be like this. It will be shifted 1 units in the downward direction. So this is the graph of y equal to mod x minus 1, right? And now I have to take the whole mod, right, mod of this quantity. So mod of this quantity means it will always be positive. So whatever region is there in the negative part, right, this region, whatever region is there in the negative part, I will take the mirror image of this above the x-axis, right? So the negative part, for the negative part I will take the mirror image above the x-axis. So this graph will become like this. So actually what will be the graph of this function? The graph of this function will be, just you have to apply the simple transformations of the graph, right? So the graph of this function will be just like this. This will be the graph of y equal to mod x minus 1. Okay, and now clearly from the graph we can see that where this function is differentiable, not differentiable. This function is not differentiable where there are sharp corners, and we have this point is x equal to minus 1, this point is x equal to 0, and this point is x equal to 1, right? So we have sharp corners present at x equal to minus 1, sharp corner at x equal to 0, and x equal to 1. So it is non-differentiable. This function is non-differentiable at all these 3 points, 0, 1 and minus 1. So A would be the correct answer. This question was asked in IIT JEE 2005, right? So just you had to plot the graph of this, and for plotting the graph of this you have to use the concept of graphical transformation, right? Plotting a graph is very important. If you can plot the graph of any function, then you can tell about continuity, differentiability, limit, everything, right? Once you know the graph, you know everything and anything about the function, right? You can have the complete post-mortem, complete analysis of that function, right? If this is the graph of the function, we can clearly see from the graph that there is a sharp corner at this point, and at this point, at all the 3 points, right? So it will be non-differentiable at all these 3 points. Okay, so it will be non-derivable at 0, 1 and minus 1. Okay, that's it. Okay, let us see the third question. Again, this question is also very simple. It was asked in JEE 2006, and this question, this function might not be very familiar with some of the students who have not studied this function correctly, right? This is minimum of 1 x square and x cube, right? Minimum function. Now see, whenever there is minimum function or a maximum function, what is the method that I will tell you, right? Whenever you find out this type of function, minimum of 1 x square x cube, what you do is first you independently plot the graph of all these 3 functions. So y equal to 1, y equal to x square, and y equal to x cube. First you should independently plot the graph of all these 3 functions, right? So if I plot the graph of all these 3 functions independently, so what will be the graph of x square? Graph of x square will be something like this, parabola upward, right? This is the graph of y equal to x square. What will be the graph of x cube? The graph of x cube will be something like this. This is y equal to x cube, and both of them will intersect at x equal to 1. Right, this point is x equal to 1 because x cube equal to x square, so they will intersect at x equal to 0 and x equal to 1, right? And what will be the graph of y equal to 1? Y equal to 1 will be a straight line, constant graph, right? This is the graph of y equal to 1. Now we have to take the minimum of all 3, right? So what will be the minimum of all these 3? The minimum of all these 3 means we have to take the graph which is the lowest one. So which is the graph which is lowest? Here this graph is the lowest, then this graph is the lowest, and after this graph is the lowest. Okay, so what will be the graph of this function, minimum of all these 3? So the graph of this function fx will be nothing but it will be x cube till x equal to 1, and after x equal to 1 it will go like this. It will be y equal to 1, straight line, right? This is a straight line, y equal to 1, and here it will be the graph of y equal to x cube, right? So from the graph itself you can see that this graph is continuous for all x, right? Because we don't have to lift the pen. See, if I draw the graph of this, I don't have to lift the pen. I can directly draw the graph like this. So this is continuous for all x. This option is correct, right? This graph is continuous everywhere because we don't have to lift the pen anywhere, right? So this is continuous, and also it is differentiable at x equal to 0 because at x equal to 0, because for f of 0 minus also, right? For 0 minus also it's following the graph of x square, and for 0 plus also it's following the graph of x cube, x cube, right? For 0 minus and 0 plus, both these values, it is following the graph of x cube only. So at x equal to 0 also it is differentiable, right? At x equal to 0 it is differentiable, but it is not differentiable at x equal to 1. This point is x equal to 1, right? Because there is a sharp corner at x equal to 1, sudden change in the graph, right? It was going like this and suddenly it became constant. So there is a sudden change here. So this is a sharp corner at this point A. So it is not differentiable at x equal to 1, right? So it is continuous everywhere. It is not differentiable at x equal to 1, but it is differentiable at x equal to 0. Now you can check out which is the correct option according to this and take the correct option, right? So this is again a very simple question, and if suppose there was a maximum, right? If maximum was written here instead of minimum, if maximum function was asked, in that case you will take the function which is the highest of all 3, right? The graph which is highest of all 3. So in that case you would have taken this graph, right? This graph which is highest, right? So above one, upper one of all three. So here it will be x cube. So the graph would have been like this, and then following the graph of x cube, right? Then this would have been the graph of maximum of all these three, right? That fx, which is maximum of all these three. Okay, so this is again a very simple question which was asked. Again, this was based on the graphical interpretation of the graph. So it shows that in IIT JEE exam, graphical interpretation is very necessary. If you can plot the graph of any function, then you can tell about continuity, differentiability, at which point it is differentiable, which point it is discontinuous, right? All this information can be given from the graph itself. Okay, let's see the next question. Next question says that, now in this question it is given that fx is given, right? This function is given, and we have to find out whether this function is fx is continuous at x equal to minus pi by 2. It is not differentiable at x equal to 0. It is differentiable at x equal to 1. So we will check about the continuity and differentiability of this function at all the values of x, right? Let us check continuity and differentiability at all the values of x, right? So suppose first of all I will check for the continuity of the function, where this function is continuous and where this function is discontinuous, right? So I will have to check at the critical point where the definition of the function is changing. So first of all let me check at this point, which is x equal to minus pi by 2. Now if I want to check for the continuity, right, first of all I am only checking for the continuity, whether it is continuous or not, right? So if I want to check for the continuity, what should be the condition? If fx is continuous at x equal to minus pi by 2, then LHL equal to RHL equal to f of minus pi by 2 equal to finite, right? This is the condition if fx is continuous at x equal to minus pi by 2, right? So in this case LHL will be nothing but minus pi by 2 minus, and RHL will be minus pi by 2 plus. So what will be the value of minus pi by 2 minus? If x is less than pi by 2, then I will put x equal to pi by 2 in this, minus pi by 2 in this. If I put x equal to minus pi by 2, I will get minus pi by 2 minus of pi by 2. So this will be nothing but 0. And if I put x equal to minus pi by 2 in this, then again I will get minus cos minus pi by 2, which will again be 0. Right, so LHL is equal to RHL is equal to the value of the function, so we can say value of the function will also be same, right, because this is greater than equal to. So at x equal to pi by 2 also the value of the function will be 0 only, right, it will be just equal to the LHL. So here we can say that it is continuous at x equal to minus pi by 2. Now let me check the value, now let me check whether this function is continuous or not at x equal to 0. Second critical point, at x equal to 0, so I will have to find out what is f of 0 plus, and I will have to find out what is f of 0 minus, right? Now what will be f of 0 plus? F of 0 plus, so x is greater than 0, so put x equal to 0 in this, I will get 0 minus 1, which is minus 1, and put x equal to 0 in this. If I put x equal to 0 in this, I will get minus cos 0, and minus cos of 0 is also minus 1. So again I can say that LHL is equal to RHL, so fx is, so this function is continuous at x equal to 0 also, right? Now let me check at x equal to 1. Right, this is the next critical point that we are having. So at x equal to 1, so find out what is f of 1 plus and find out what is f of 1 minus. Now for 1 plus, x is greater than 1, so I will put x equal to 1 in this, so ln 1 is 0, so f of 1 plus will be 0, and f of 1 minus, for 1 minus I will put x equal to 1 in this, so 1 minus 1, again it will be 0. So this is also continuous at x equal to 1. So it is continuous at x equal to minus pi by 2 also, it is continuous at x equal to 0 also, and it is continuous at x equal to 1 also, alright. So this option will definitely be correct. This question was asked in JEE 2011 in more than one correct type options, right? So more than one options can be correct. So you have to check for this options also, B, C and D. So you have to check for the differentiability of the function also, whether it is differentiable or not. Actually these two parts were not required, right? X equal to, you need not check at x equal to 0 and x equal to 1 because that was not given in the options, right? But still I told you for your information, right? So this function is continuous everywhere. For all x element of R, right, it is continuous everywhere. So it is continuous at x equal to minus pi by 2 also, right? Why it is continuous everywhere? Because it is continuous at all the critical points, and in between it is always continuous, right? So this function is continuous everywhere. Now let us check for the differentiability of the function, whether this function is differentiable or not. Okay, so this is fx. Now what I will do is I will differentiate with this function and I will find out what is f dash x. So I can directly differentiate this function, right? Differentiability I will check by differentiation. So directly differentiating, so what will be differentiation of this? Differentiation of this will be minus 1, differentiation of minus of cos x. Cos x is minus sin x, so minus of minus sin x is, this will be sin x. Differentiation of this will be 1, differentiation of ln x is 1 by x. Okay, this is if x is less than equal to minus pi by 2, this definitions will remain same, right? So 0, pi by minus pi by 2, x going from 0 to 1 and then x greater than 1. Right, now let me check whether this function is differentiable or not at x equal to, let me take the first point first. So x equal to minus pi by 2. Now if I want to check whether this function is differentiable or not at x equal to minus pi by 2, I will have to check for LHD and RHD, right? So left hand derivative should be equal to right hand derivative should be equal to finite. So what will be left hand derivative? Left hand derivative will be f of minus pi by 2 minus, and right hand derivative will be f dash minus pi by 2 plus, right? So what will be minus pi by 2 minus, so f dash, right? F dash is this function. So now I will put x equal to minus pi by 2 in this and x equal to minus pi by 2 in this, right? Minus pi by 2 minus means x is less than pi by 2, so this definition will follow. So here x is constant, y is constant, which is equal to f dash is equal to minus 1 here, and if I put x equal to minus pi by 2 in this, I will get sine of minus pi by 2, which is again minus 1. So here we can say that LHD is equal to RHD, so it is differentiable at x equal to minus pi by 2. Now check at x equal to 0. At x equal to 0, I will have to find out the value of f dash 0 plus and f dash 0 minus. What is f dash 0 plus? F dash 0 plus, I will put x equal to 0 in this, which will be 1, and f dash 0 minus, I will put x equal to 0 in this, because x is less than 0, right? So here sine 0 will be 0, right? So here we can see that LHD is not equal to RHD. Left hand derivative is not equal to right hand derivative at x equal to 0, so it is not differentiable at x equal to 0. Now let me check at x equal to 1. At x equal to 1, I will have to find out what is f dash 1 minus and f dash 1 plus. So f dash 1 minus means I will put x equal to 1 in this. This is a constant function, so it will remain same 1. And I will put x equal to 1 in this for f dash 1 plus. So 1 by 1, which is nothing but 1. Right, here again LHD is equal to RHD. Left hand derivative is equal to right hand derivative. So again it is differentiable at x equal to 1. So I can say that this function is also differentiable everywhere except, okay, it is differentiable everywhere except which point? Except this point, which is x equal to 0. It is not differentiable at x equal to 0, otherwise everywhere it is differentiable. So which options will be correct? The options which will be correct is, it is not differentiable at x equal to 0, this is correct, it is differentiable everywhere. So it is differentiable at x equal to 1 also, and it is differentiable at x equal to minus 3 by 2 also. Minus 3 by 2 will be somewhere in between this values, right? So obviously there it will be definitely differentiable, right? Because there is no break in the definition of the function, so it has to be differentiable, because all these functions are also differentiable, right? So this was again a simple question, and here the correct answer is all 4 parts A, B, C, D. It was asked in more than one correct type questions. The correct answer would have been A, B, C and D. All options are correct, everything is correct, okay? So this was again a good question which was asked in JEE 2011. Again it was a very simple question, you just have to check at each and every point. That's it, by applying the basic definition of continuity and also derivability. So both the concepts were checked by just one question. Okay, now let us solve the next question, which is fx is equal to, again the function is defined like this, and it is asked that then f is differentiable at x equal to 0 and x equal to 2, differentiable at x equal to 0 but not at 2, at 0 but not at 0 but at 2. So basically we have to check whether this function is differentiable or not at 2 points, right? One is x equal to 0 and second is x equal to 2, right? At 2 points we have to check. So let us check whether this function is differentiable or not first at x equal to 0. Now if I want to check whether this function is differentiable or not at x equal to 0, I will have to find out LHD and RHD, right? So what will be RHD? Right hand derivative at x equal to 0. So at x equal to 0, this will be limit h tending to 0, f of 0 plus h. First always write down the definition of RHD, right? F of 0 plus h minus f of 0. F of 0 is 0, right? It is given in the question. At x equal to 0, the value is 0. So f of 0 is 0 divided by h, and what will be LHD? LHD will be nothing but limit, right, h tending to 0. Here it will be f of 0 minus h minus f of 0 divided by minus h. Now if I put x equal to h in this, I will get limit h tending to 0. Here I will get h squared mod of cos pi by h divided by h. Now one h will get cancelled with this h, but still one h will remain, right? So 0 into some quantity. So 0 into some quantity will be 0, right? Because h is tending to 0, so one h is left here, which will be going towards 0. Now here again I will get limit h tending to 0. Now I will put x equal to minus h in this, right? So minus h whole square will be again h square, and here I will get cos of pi by minus h. Now again cos of minus x is cos x only, right? So I can just write this as h divided by minus h. So 1 h will get cancelled, 1 h will still remain. So again this is 0 into something, so the value of this will also be 0, right? Because h is tending to 0, this 1 h will remain here, right? Which is tending to 0, so it will be 0 into some quantity, finite quantity, and this will be equal to 0. So in this case at x equal to 0, I have LHD equal to RHD is equal to finite, which is equal to 0, right? So I can say that it is differentiable at x equal to 0. At x equal to 0, this function is differentiable, okay? And now let us check whether this function is differentiable or not at x equal to 2. At x equal to 2, what will happen to this function, right? So this function will be defined like this, right? If x is less than 2, right? If x is less than 2, this function, this mod will open in, right? If x is less than 2, here I will get at, what is the graph of cos x? See, the graph of cos x is like this, right? It becomes 0 at pi by 2, right? It becomes 0 at pi by 2. Now if x is less than 2, okay, if x is less than 2, that means denominator is less than 2, right? So that means this quantity will increase, right? Pi by less than 2, right? So 2 minus, this will be how much? Pi by 2 minus, so this quantity will increase, so this will be greater than pi by 2, right? So if I take x less than 2, that means I will get, if this is greater than pi by 2, then cos will be negative, right? In this case cos will be negative, so this mod will open with a negative sign. So I will get cos of minus pi by x, and if x is greater than 2, then this mod will open in positive. So x square cos of pi by x. Now if I differentiate this, what will be f dash x? If I differentiate this, you can use the product rule for differentiating, right? So you can just do it as first function into differentiation of second function, like that, right? So what will be first function into differentiation of this? So the differentiation of this will be cos, so differentiation of cos will be sine, okay? Or first you can differentiate, yeah, so this will be how much? Into cos, so cos will become sine minus sine, so sine of pi by x, and what will be the differentiation of this? This quantity will be into pi by x square, minus 1 by x square, right? So basically this quantity will go plus second function, so cos of pi by x into differentiation of this, which will be minus 2x, right? So you can use the product rule for differentiating. So same way here you will get how much? Here you are getting pi, so here you will get minus pi sine of pi by x, plus here you will get plus 2x cos of pi by x, right? Now if you want to check whether this function is differentiable or not at x equal to 2, then you will have to find out what is f dash 2 plus and what is f dash 2 minus. Now if I find out what is f dash, this quantity will become 0 at x equal to 2, right? Because cos pi by 2 is 0. So both these quantities will go, this will become 0 and this will become 0. So it will depend only on this term, okay? So from here, this is if x is less than 2, right? This definition is if x is less than 2. So for 2 minus, the value of this will be sin pi by 2 will be, if I put x equal to 2, here sin pi by 2 will, this quantity will become 1, and here I will get nothing but, this will be minus 1 by x square, right? So this will be minus pi and this will be plus actually, right? So if this will be plus, how much I will get? Here this quantity will be pi, right? So one of them will be pi and one of them will be minus pi, okay? So both of them are not equal. LHD and RHD are not equal, okay? So if LHD and RHD are not equal, actually for 2 minus it will be plus pi, right? This is minus pi and there was a minus sign here, so both of them will become plus, and here it will be negative, yes. Okay, so you can check the calculation here. So this will be negative, and for minus 2 minus, yes, it will be positive, right? So this is minus pi and this is plus pi. So both of them, LHD is not equal to RHD. So again we can say that it is not differentiable at x equal to 2. So which will be the correct option? The correct option will be it is differentiable at x equal to 0 but not at x equal to 2. So option B will be the correct answer, differentiable at 0 but not at 2. So again by using the definition of LHD and RHD, you can find out whether it is differentiable or not, and this was asked in recently in JEE 2012 itself, right? So you can see that the questions of JEE are very simple, right? Just you have to focus on the basic concept, right? What is the basic concept is, you have to find out LHD, RHD and check whether LHD is equal to RHD is equal to finite, right? There is only one definition for continuity and one definition for derivability, and you have to stick to that definition, right? Stick to that definition of, okay? And the questions based on on the definitions will definitely be asked, right? They want to check your basics. So this is the basic, right? So definitely questions will be asked on this basic only, and it will be very easy, right, if you know the basics. So I hope you enjoyed solving questions with me, and you can see how questions asked in IIT JEE exams are very simple, right? So I hope you enjoyed it. Thank you. If you have any doubts, then you can log into www.askIITians.com, and then you can click on the discussion board, which will redirect you to this page where you can see Ask Expert on the right hand side. From here you can select the category of the question and you can post your question here for free, and the experts at Ask IITians will answer your question within 24 to 48 hours. So students, I hope that you enjoyed watching the lecture series of continuity and differentiability by me, right? And so let us summarize quickly whatever topics that we have studied in this lecture series. So we started off with the definition of the continuity, and then I told you about the basic definition of continuity. After that I told you about different theorems which are related to continuity, and after that I told you about continuity of composite functions, and then after I told you about differentiation or derivability, its definition, and we also talked about the various theorems which are related to differentiation or derivability. After that I also told you about what are how to encounter whether a function is derivable or not by actually differentiating the function, and at last we solved some IIT JEE previous year questions that appeared in the examinations. So I hope you enjoyed the process throughout. Now for more videos on biology, chemistry, physics and mathematics for other chapters also, you can stay tuned on askiitians.com for more videos. Thank you, good night, goodbye.